Hello, everyone, and good evening. Welcome to today's webinar on From Zero Coverage to Production Ready, Mastering Inherited Code Bases. I'm Ömer Tümer, Head of Marketing at Diffblue, and I'm joined by Animesh Mishra, our Senior Solutions Engineer, who will be showing you a live demo of techniques we'll discuss today. Before we dive in, though, a quick note: we are recording this session and we'll send it to all registrants within 24 hours, so you'll be receiving an email about that. If you have to leave a little bit early, that should be okay. We'll also have a Q&A at the end, so please use the chat for the questions throughout, and then we'll go back to those questions at the end of the demo. Now, let me start by asking a question. How did you inherit your code base? Let me share my. Can you see my screen, Animesh?
Yes, we can. Yeah.
Perfect.
Thanks.
Great. Let me.
We can see the quiz as well. Thanks.
Yes, great. So let's start with a show of hands. How did you come to manage the inherited code through an acquisition, a team transition, or maybe bringing development in-house, or perhaps taking a new, you are in a new team, take on an existing system? Let's put a few minutes for this as well. Right. So I can see that there are people who have been having team reorganization or code original developers are no longer in the organization or other. Good. We've been having conversations this year with over 50 engineering leaders, and then we've come across with a few patterns that is shared across different companies. First of all, 73% of them were working on inherited systems below 20% test coverage. So there was definitely massive room for improvement. The typical inherited code base in these large enterprises is consisting of 3 to 5 million lines of code. So there's substantial assets to leverage for creating value for the company. And average time since knowledge transfer has been over 18 months. So systems have proven their value. But then the people who have been there building these systems or maintaining them maybe are not there anymore. And current documentation is usually very low, under 10% among these people who have been in our pipelines. Obviously, these are not always problems. They're also starting points for transformation, and then we believe that there's value in turning this into value. One of our customers this year described the situation perfectly. After their acquisition, the engineering lead said, "We are looking at an abyss, inherited code base with no test coverage, original team gone, and we needed to integrate by the quarter's end." This is definitely not unique to them. Few scenarios that we see repeatedly are, first of all, the post-acquisition integration. In many cases, there's a company which invested millions in acquisition of a new company. There's inherited code base that's proven and that's been serving customers for years. And the original team moved on after the acquisition because the integration takes time. And there's usually board level expectations when it comes to the integration within months. But at least you are not beginning from the zero. You are starting with a battle tested code that just needs the right foundation to thrive in its new home. Second scenario that we come across are related to from vendor code to in-house transitions, bringing vendor or SI code in-house after 6-7 years. That's obviously 6-7 years of refined business logic, and now under the control of the in-house team. It might be that those comments that are part of the code base are in another language. Maybe if this vendor was offshore, or they're clues to international market knowledge, and your team's caution your team is cautious about the changes, and obviously it's a professional wisdom. They recognize the value and preserve what has been serving them while modernizing it. The third scenario that we are coming across, of course, as also it was in the poll, the team changes. Sometimes senior engineers move on. Obviously, it's a natural transition. They build something solid enough to survive without them. Most of the times, but sometimes it's not the case either, right? So your new team brings fresh perspectives and modern approaches, and they shouldn't be handicapped by missing contacts, and they should be empowered to improve the existing code base. The real impact of these cases with low coverage are usually showing themselves as delays in merger and acquisition synergy. That's delayed team productivity. A large part of engineering time spent on understanding the code base and not building. The business risk, for example, we documented cases like one customer who experienced 3 production outages in the first month with the inherited code. But at least the encouraging part is that with proper test coverage, these are completely preventable and it's a solvable problem. And finally, the opportunity cost, obviously, the features delayed, innovations stalled, or competitors advancing, while inherited code can slow innovation temporarily. And companies that solve this kind of challenge systematically often emerge stronger. The usual pain points in this kind of cases where there's an inherited code base, few things that we are seeing again across the board. First of all, the unknown behavior. Comments and documentation obviously tell you the intentions of the code, but code reveals the actual behavior. So when you have 5 million lines of code to understand, you need a smarter approach. One engineering director this year told me we spent 3 months documenting the system. Then we made our first change and discovered our documentation was wrong. So the code had undocumented side effects everywhere. Secondly, team paralysis. Your senior engineers are obviously being thoughtful with inherited code, and that's exactly the type of maturity that you want to see as an engineering leader. They understand the value at stake and they're ready to contribute brilliantly, but they just need the right environment. So the proper test coverage again acts as a safety net, and we've seen teams transform from cautious to confident in months, if not weeks. The third thing is, of course, the deadline pressure. The clock is ticking, whether it's board expectation, compliance requirements, or integration deadlines. Usually, you don't have time for gradual documentation or coverage. Merger and acquisition integrations usually happen within 3 to 6 months. Compliance audits have quarterly gates, or vendor transitions obviously end when the contract ends with them, right? So that's another pain point that we are seeing. And finally, a modernization trap, moving from Java 8 to Java 17 maybe, or transition from monolith to microservices. These are not only technical upgrades for inherited code bases, but there are also opportunities. And with comprehensive test coverage, modernization becomes an acceleration and not a risk on its own. What we've been doing for the last 20 years and more, why traditional approaches fail, the teams typically try a few things, right? The consultant army, bringing in consultants makes sense as they bring fresh eyes and dedicated resources and structured methodology. The investment is significant and their work usually would take 6 to 12 months. But once again, the documentation that they would create captures a moment in time while the code evolves continuously. So it's not runtime behavior once again, and then smart teams are realizing they need something more dynamic. The second option, again, that's now the legacy option, maybe manual testing. This is a good instinct, obviously, and your team writing the tests would mean that they truly understand the system, but the math maybe just doesn't add up, especially for the legacy systems or inherited code bases. If you have hundreds of thousands of tests that you need to write at maybe 20 minutes or 30 minutes each, you would need years, and you definitely do not have years, but months with this kind of inherited code bases. And that's what modern automation enables, in the same direction of manual testing, but definitely in a more accelerated manner. Choosing the right AI for the job. Obviously, as I said, the manual testing is becoming the legacy option, except the edge cases. And then we are using much help from the AI coding assistants. So you might have thinking, you are, I'm sure, using already Copilot or similar AI coding assistants, and that's brilliant transformative tools that we also use and recommend every day. But the question isn't whether to use AI, it's about choosing the right AI approach for your specific challenge. So before I give the word to Animesh, let's explore what it means for inherited code bases. First of all, there's definitely a context problem, right? AI coding assistants are designed as pair programmers. They amplify your understanding. And when you know what a method should do, Copilot helps you write the test faster. It's a productivity multiplier, but inherited code presents a different challenge. You need to discover what the code actually does and not what you think it does. And that requires behavioral analysis and not pattern matching. Second thing is the hallucination risk. LLMs work on probability and patterns from training data. They generate what's most likely based on what they've seen before. For new code that you're writing, that's perfect, and you can guide and verify. But for inherited code processing, critical business logic, you need certainty, not hallucinations or probability. You need to know exactly what happens at runtime, not what typically happens in similar code to yours. And finally, the scale challenge. Copilot accelerates individual test writing beautifully, maybe making developers 5 to 10x more productive, and that's incredible for ongoing development. But with inherent code bases needing comprehensive coverage immediately, hundreds, thousands of tests across 5, 6, 7 million lines of code, even with 10x productivity, you are looking at years of effort, and that calls for a different approach, which is full automation at scale. So to sum it up, codings are perfect for new feature development, code that you understand, incremental test creation, pair programming scenarios, learning and exploration. Whereas for autonomous test generation, you need are designed for inherited systems at scale, unknown code behavior, comprehensive code coverage, runtime verification, and rapid baseline establishment. So from what we are seeing, the most successful teams use both autonomous testing to secure inherited code quickly, and then Copilot for ongoing feature development. So it's usually not an either or situation, but it's using each tool where it excels. How are the leading enterprises like Citi, Workday, Goldman Sachs are transforming inherited code bases into competitive advantage? These are our customers, and then we are seeing three principles that they're sticking to. One is behavioral discovery through execution. Instead of guessing what code might do, they're discovering what it actually does through runtime analysis. You see the real behavior and not the assumptions. Secondly, autonomous scale that matches the timeline. They're achieving comprehensive coverage through full automation, transforming months of work into days of execution. And finally, continuous evolution with their code. As systems evolve during integration, test coverage evolves automatically. Every change is protected, and every regression is code, as you might have heard or now hearing. Obviously, Diffblue cover works in CI as well. What you'll see next with Animesh, Animesh is about to show you this approach in action. You'll see an inherit code-based transformation in real time, comprehensive test generation at scale, regression protection during active integration, and teams going from cautious to confident. You have an inherited code base and a deadline. And the traditional paths are well understood, the documentation projects, the gradual testing, AS, the development, and these are all valid approaches for different scenarios. But if you need comprehensive coverage measured in quarters and not years, and if you need your team to be productive now, not eventually, then you need an approach that's designed specifically for this challenge. Animesh, would you like to demonstrate how we are helping companies turning inherited code from liability to advantage?
Yes, yeah. Thanks, Amar, for that preamble. Hello, everyone who's watching. My name is Animesh. I'm the solutions engineer at Diffblue. And what I'm going to do for the next 20, 25 minutes is I'm going to pretend I'm a developer who's inherited an application with very little, actually no testing whatsoever. And I'm going to use an AI tool, Diffblue, to generate unit tests for that. And what we're going to see through that process is how Diffblue goes about doing its business. It's very different from other AI tools. We don't use LLMs, for example. And we're going to see how that different approach produces a qualitative different outcome. So let's get straight into the live demo. I will share my screen. Give me a shout, Omar, when you see it.
Yes, perfect.
Perfect. So you left it at a perfect point. There is a better way, but what does that better way look like? So we've been doing this for a while. Diffblue's been around since 2017, and we predate a lot of this LLM hype as well. Uh, we've designed our product on three key product pillars. The first is our deep domain knowledge of Java itself. When Diffblue picks up your application to write tests, it's not just looking at the plain text Java source code. It is also capable of processing and, most importantly, which is the second pillar, executing your Java bytecode to understand and observe the runtime behavior of the code. So those two together, our understanding of how Java works and our ability to then execute a piece of Java code to observe its behavior, allows a third pillar, which is our in-house reinforcement learning algorithm, to fashion a unit test that doesn't just run, it will exercise the right code under test, and most importantly, the assertions that it has reflect the true runtime behavior of your code. So what you get is an AI tool that's not just chancing it, that's not just having a guess, it's actually picking up your code, looking at what libraries and frameworks make it, then actually executing the method under test to observe all the effects and side effects of that code, and finally creating a bunch of test cases that document all of that behavior. So what you get is a unit test suite that not only works the moment you write it, but also helps you prevent regressions as you go and make code changes to your project. And all of this AI smartness, the analysis, synthesis, analysis is completely deterministic. So if you give it the same piece of code, Diffblue will always write the same unit test. And this predictability is what allows you to then start trusting the AI. One of the things that I found most difficult in letting AI just take over my job is that even though I do use things like Perplexity and Claude, they are inherently probabilistic tools. So they will give me the right answer sometimes. They will often also give me the wrong answer for the same question that I've asked again because I forgot that I asked it a few days ago. And so that inherent probabilisticness of that, which Omar mentioned in hallucinations, that is what prevents developers from fully trusting something. We are much more amenable to trusting a shell script because it's more deterministic. We know exactly what's going to do before and we can reason about it than something that's a black box thing and we put an input in and hopefully the output is right, hopefully the output is wrong. That's not a risk you need to run with Diffblue. Deterministic system, you run it on your application. If you like the test that it's outputting, you can bet your money on the fact that if you don't change your code, it will produce the exact same test case every single day until the cows come home. So let's see it in action. What I'm going to show you are three things. The first is I'm going to show you in a command line interface, which allows you to write a full unit test suite from scratch in an application. So don't forget, I'm a developer. I've inherited this app. There's been a company reorg. I've just ended up on this team. There's an application I'm working with. There's no unit test in it. So what I want is a solution that will allow me to quickly get that catch-up coverage. So that's what we're going to see first using the command line interface. We also have an IDE plugin, which can generate tests. but we'll start off with the command line interface because that's what's designed to write tests at scale. Then, once we have this test suite, I would naturally make a feature change because that's what my team would expect of me. And I'll show you how you can use the IDE plugin and the CI integration to keep this Diffblue test suite up to date. So it's not that it can only write tests once. It will write tests once, then you make your code changes. It will then update those test suite for you. And finally, we'll look at the outcome of all of this back and forth with the AI using something called Cover Reports, which is our analytic application, which allows you to see not only how much coverage you're getting in an application through Diffblue, but most importantly, where are the testability gaps in your code and what can you do to make your code more testable. So we'll see all those three things in the action in the next 20 minutes. Let's get straight into the demo. So what I'm going to use for this demonstration today is a Spring application developed by the Spring Framework team called Pet Clinic. Why have I picked this application? Seems quite simple. That's true. It's a rather simple application. But the key thing I want you to take away from this demo is that Diffblue AI is able to observe the behavior of the application and then write tests that capture it. So if I pick up something complex, I'm going to have to spend 30 minutes just explaining how it works before we can get to the test. So that's the reason for picking this application. Once we get to the test, you will see that all of the framework feature that the class under test uses, we use day to day in our life as well. So all of the learnings will be easily transferable. To kick off test creation for this application, I'm going to, in my terminal at the root of my project, I'm going to run a command bcover create with some flags. Diffblue is, well, like I mentioned, not an LLM-based tools, which means that all of that chatbot-like experience or bartering with with an LLM, that doesn't need to happen here. We've given it's an agent. We've given it a task. It will go and execute the application, identify what needs to be tested, and we'll go write a bunch of tests for every single class and method in there. So I don't need to babysit it. All I had to do was just run this one command. We can put this in the background, go do something more important in our lives, and come back, and Diffblue will have then come and updated the test cases. Hang on a sec. I'm going to be back in a sec. My room just went very dark.
Animesh, can you hear me?
Yeah, I'm back. It was just
Okay.
depressingly dark, I mean, as is England sometimes with the weather. Right. Okay. I think you can see me again.
Yeah, perfect.
Perfect. Awesome. So this particular application, I've run that command in the terminal. Let me show you a feature in here. It's quite nuanced behavior, and I wonder if Diffblue will be able to pick that up and write tests for that properly. So this particular search form, allows me to search a list of pet owners by their last name. There's a neat little optimization built in here. So if you look up a name that's rather common, such as Davis, and there are multiple Davises in my database, I will get shown a paginated list of all the Davises. Whereas if the name I'm looking up is just unique in my database, occurs only once, I skip that pagination logic and get taken straight to the profile. So multiple items in the search result in a paginated list. Single item results in a redirection instead. That's how the application works and looks like to us as users. Let's have a look at the code that powers that search form. So it's this process find for method that powers that search form. And what we just saw is the result of these 4 lines in the code base. If there are if there's a single item in the result, it makes the website redirect to the owner profile. And when there are multiple items, we see a paginated list. So that's the code in the test. We've seen how it works. I've asked Diffblue AI to go write tests in the terminal. It's going to finish in a second, but while it's doing that, it's already made its way to the owner class. Now it's writing tests for the owner controller. While it's doing that, let me tell you how this all works underneath. Now, the moment I run that command, a couple of things happening on my laptop, because this is an on-device AI. There's nothing that is sent across the world to be processed and then pushed back down. If we were all in a room together, I could do this demo completely offline. So when I ran that dcover create command, two things happened. Diffblue will first do a static analysis of the project just to understand its structure, how many classes are there, what sort of frameworks and libraries it's using, so on and so forth. Once it's done that, it will identify, okay, this is the project I'm working with, and I want to write tests for method X. To write tests for method X, Diffblue will create a JVM, will run a JVM on your machine. We call this the Diffblue sandbox, and it will run that method X in that sandbox. By running it, your method in the sandbox allows us to capture what we call external calls. Things like file system operations, network calls, third-party library methods, all the things that you would typically mock in a unit test. This is what this setup allows us to do. What it also allows us to do is actually run your method and see what does it do. How does it change the application state as it runs and when it finishes? We package, we learn all of that context, and then we predict a unit test case for this method. So we start at the bottom left of this diagram. If we predicted a test, we then run that test against your code and evaluate its effectiveness. We're looking at coverage obtained, both line and branch. We're looking at how readable the unit test is. Is it using the right idioms? And a few other secret metrics which help us answer the code. Is this a good unit test? If the answer comes out no, which could be for any number of reasons, maybe the test doesn't compile, maybe it compiles, but it doesn't really give us much coverage, or maybe it gives us a lot of coverage, but the way it's mocking things is it's not nice, it's not idiomatic enough. For any number of reasons, what Diffblue will do is if it doesn't pass a quality threshold, the created test will get rejected. Diffblue will hoover up all the context we have learned through this exercise, through this iteration, and then predict a better test. And we keep going through this loop 1,000 times a second until we get to a unit test that always runs. It exercises the method under test, and most importantly, has assertions that reflect the true runtime behavior of the code. But that is the Diffblue deterministic machine learning algorithm in action on device. It writes unit tests for you in a matter of seconds. So if we come, oh, sun's gone down. If we come back to the terminal, it's finished writing the owner controller class test. So I will switch back to my terminal here, and let's have a look at the test case written for us. So here, recall we're testing the process find for method, and in there we're particularly looking at the two scenarios when we had a single item in search result, we saw a redirection occur. When there were multiple items in search result, we saw a paginated list instead. The test on my screen is the scenario. Actually, before we look at the test, let's just look at how this class looks like. So all we've done so far is I've run a single command in the terminal, and then I've been going and showing you a bunch of other things, talking about what Diffblue does and how great it is. Meanwhile, what Diffblue had been doing was running this application, trying to understand that, okay, this owner controller is a Spring controller class. I know to test Spring controller class, I'm going to have to use Spring context. I'm going to use the right annotations. I'll also have to auto-wire stuff and mock the right beans. So it's all aware, context aware, the fact that when there's a given framework in place, we must use the right annotations and right idioms for testing that framework's code. So in this case, it's picked up, this is a Spring framework code. I didn't tell it, I just ran a command. It's just smart enough to pick that up by itself. So once it's done that, I'm going to run this command with coverage just so we can see my claim that all the tests run, to exercise the method under code, under test, and most importantly, the assertions reflect how the code works. So the first two, all the tests do run, which is great. And we managed to get 95% coverage, which is awesome. The most important thing here is the fact that it is actually exercising the code under test. There's been a lot of times I've tried using other LLM-based tools where I've asked them to write a unit test, and they've written an excellent unit test. The only problem is not much of it exercises the code under test. Sometimes they just mock the class they're trying to test, which just defeats the whole purpose. So that's the key thing to take away from here, that these tests are not just tests for their own sake. They're actually exercising the code that you've written. But none of this 95% is fun or useful unless these tests can capture regressions. And the only way they catch regressions is if they have assertions that are actually asserting on the real behavior of the code. So we come back to the test, which deals with the scenario where there's a single item in my result. I saw a redirection occur. Let's see what this test is doing. So all the tests that Diffblue write will come out in its standard arrange, act, and assert pattern. What Diffblue has done here is created some test data up front. We ship with a limited dictionary, which allows us to create test data for common entities such as address, city names, people names, phone numbers. But when things get a lot more domain specific, which they will inevitably do, we also have a custom inputs feature, which allows you to supply your own data. So you're not limited to what we can produce out of the box, but we can produce some test data to get you started. So we created this single owner to simulate the behavior that there's only a single result that we're going to get back from the database. Then we're mocking the repository method to return that. And finally, using mock MVC to drive the search and assert on the fact that when there's a single item coming back from the database, we will see a redirection happen. So that is exactly how the application works as we've seen it. And now there's a unit test here for me as a developer who knew nothing about this application to refer to and see, okay, I see what's going on. This is how it works. Now, I can show you the other one as well. The second scenario where there's multiple items in the search result. So we created a bit more test data. Diffblue is smart enough to create unique instances. So you've got a Jane Doe and a John Smith, and we'll keep going and creating more unique stuff as required. And then the rest of the test is quite similar, using mock MVC to drive the search, but this time asserting on seeing a paginated list because that's how the application works. So test that runs, exercises the code under test, and most importantly has assertions that tell me as an unfamiliar developer, what does this code actually do? Now that I'm armed with this code, what I want to do is go and make some changes to it and see what happens. So I'll come back to my owner controller class and let's say Omar, my manager, comes to me and says, Animesh, all this redirection logic just makes me very dizzy. Just get rid of all of that. I just like seeing pages everywhere. So I'd say, okay, fair, no problem. I'm going to get rid of that logic. So regardless of the number of items in the search result now, we're going to see a pagination occur. At this point, if I go back to my test suite, if the test suite is written well, I expect some test cases to fail. If no test cases fail, that tells me that these tests don't really work. If all test cases fail, that also tells me that, well, these test cases are just written in a weird fashion. Because I know I don't know this code, so I'm just going to run this now to see. I'm expecting a couple of test cases to fail, but let's see what happens here. Perfect. So I was expecting a couple of test cases to fail, one for process find form, one for show owner because they share the same code. So that's perfect. That's fine. What I want to do at this point is update my test suite to match the new behavior that Omar has asked me to introduce. So so far with the command line, I've managed to create a baseline test suite, which is this test suite that tells me how the application works. Based on that knowledge, I said, okay, now I feel confident enough to go and make a code change, which I've now come and done. The final thing left for me to do is now update my test suite so it becomes in sync with this new feature I've introduced. I could always go back to the command line to do this because recall Diffblue is a deterministic tool and the only line of code I've changed is this one. So if I run Diffblue at this point on the entire application, the only test case that is going to change will be the test cases that are affected by this line. But there's a neater way to do this, a more developer-friendly, ergonomic way, which is to use the Diffblue plugin. So you can download the plugin from the IntelliJ IDE's plugin store. We only have a plugin for IntelliJ IDE at the moment. So we go there, search for Diffblue cover. It'll come up. We just pushed an update, so I'm behind one. That's fine. I'll live with that. And once you've installed it, you get a nice little Flask icon in the left-hand side next to the line number. This icon in the source file will have a plus on it. It allows you to write tests for a particular method. If you're in a test file, that will have a wrench on it. You can delete your test or update your test. What I want to do is just update test for my owner controller class. I click that button, it'll definitely will spin up in here and it will do some environment checks and then we'll go and write tests. When I say environment checks, what is it actually doing? So if you recall a few minutes ago, I said we have computational understanding of your code. This is exactly how that starts. We don't ship with any unit test libraries, mocking libraries, or any sort of framework built into Diffblue. If we did, it would be a 10 gigabyte large binary. The binary is quite small, it just runs nice. So it doesn't have it knows how to write unit tests, it doesn't have the ingredients to do that. So it needs to raid your pantry. So this checking environment check, which we call pre-flight checks, it's effectively looking at your pantry, looking at the fact that this is a Maven project. We'll then pick up the POM file and see, okay, what dependencies have you in here? So we can see, okay, you've got Mockito 5, JUnit 5. You also have the JUnit Jupyter plugin for Mockito. Well done to you. And some Spring Boot tests, etc. So now, as Diffblue, I know that I have all the ingredients I need to write a test. I've got a test runner, I've got mocking libraries, and I've got some application testing frameworks as well in there. Perfect. At this point, the only check I'll make is that these are all intercompatible. So if you have Spring Web 6, for example, sorry, if you have Spring Boot 3, for example, I want to make sure that you also have Spring Boot Test 3. If you've got 3 here and 1 here, that doesn't work. So I'll raise a warning. In my particular case, excellently prepared. So everything checks out and Diffblue moves on to writing tests. But in some cases, you will see warnings here. So that's why we suggest when you first run Diffblue, the first thing you should do is do these environment checks, and it will alert you to some intercompatible projects that you might have in your project, which means right from the very beginning, as you start using Diffblue, it starts improving your project state. It starts bringing it closer to the best practices as you want it to be. Here, because I'm a clever cookie, I've already got a best practices project. All of that done, Diffblue just moves on to writing tests. And I can see it's updated my test. So what I'll do is just accept all and I'll show you what changed in the bigger screen here. So I've gone, we had failing tests, remember? We asked if we could go and update it. So because we have made a feature change and we want our test to be in sync. I'm going to run this class again to make sure that all my failing tests have gone away now. Oh, I think I made a mistake somewhere. Oh, there you go, a demo fail. Okay, I will pretend this didn't happen. I think I should have listened to the Diffblue people and updated my plugin. Always update your plugin, people. All right, cool. So I'm going to update my plugin, try it again, but I think I might have broken the plugin config at this point. So let's see. If not, then let's just pretend that you didn't see that. But while we're restarting the terminal, let's come back to the project CLI here. I'd come here and asked Diffblue to go write tests for the whole application. So discover create coverage report. It went ahead and then discovered. It did the same environment checks. So it's looking at Java version. It's looking at Jupyter API, exact same things. And it's managed to see, okay, there are 100 methods and 23 classes in that project. Nice. And then it's going class by class, method by method, writing all the tests that it can. What we see in the end is Diffblue writing 93 tests for this class, which amounts to 86% coverage in the whole application. This application that I inherited with 0% coverage, just by running this one command and waiting, let's see, 6.5 minutes, I went from having no knowledge about the project to having 86.3% of the code explained to me by these very granularly written unit tests. That's the value you can get from an AI tool that has computational understanding and that has domain level understanding of what your application is trying to do. And then it can capture it in a language and in a format that we developers understand really well, which is unit tests. So that's what the CLI did for me. Gave me 86% coverage at the bat in 6.5 minutes. And then I was in IntelliJ trying to add a new feature and update my tests. And then that demo failed. So let me try it again. And if it fails again, we will recommend that you try it on your own machine and you tell us what you find. It is sometimes because I do so many demos, and sometimes I intentionally break the plugin to demonstrate a specific feature. The IntelliJ sometimes caches settings, and then my demos break, which is often embarrassing.
All right, great. While we wait that, we are also having some questions, uh, some from Vid Romak. I hope that I'm pronouncing correctly. Should we wait until the end?
No, we can take him now while we're waiting.
All right, so one of the questions is, does it read, understand existing tests so that it skips covered classes and code scenarios?
That is an Yeah, that is a very good question. So, currently, Diffblue does not look at any existing test in the project. So, when you run Diffblue on an application, it is whether the application has some test, lots of tests, or no test, it's completely immaterial because Diffblue doesn't look at existing tests, run them, or try to do anything with them. The reason I emphasize on the currently bit is because we're working on a feature called test from tests, where the stepmotherly behavior will go away. We will actually look at the test that you have written quite carefully over time. We will run those tests. We will analyze how you're mocking your classes. We'll analyze other patterns that you're using, and then we will create our own unit tests using those patterns. So this test from test feature is coming in at the end of the year, and then we will start looking at the test that you've written. Because it's only then we'll start looking at the tests we've written. It's only then we can start excluding bits where you already have coverage and you may not want the AI to come and help you. But as it stands, to answer your question, Diffblue will go and write tests for everything in your project.
Great. And the second question is, how does it work in code that heavily depends on integrations such as DB, GMS, streams? So to say, will it generate the mocked integrations, for example, H2 for DB2, both for the unit tests, message is produced, topic is read, and for process tests such as read queue, insert into DB, modify message, and post to topic?
It will. It does try to mock database connections. Well, it definitely mocks database connections. The challenge arises, and I think that's the crux of this question. Uh, Often there isn't enough information in the code. The only input that goes into the model that writes unit test here is the code that you have written. Now you can imagine you have a method that is doing that is written to intercept a message from a queue. Now in that code, it may not be apparent what should be the shape of the message that is coming in. Because often you see, 'cause you could write your method two ways. You could write a method that is taking a string, which is a JSON string. So now that could be anything, and then it's hard for Diffblue to then reason about what this input should look like, because all it sees is this is input is typed string. It can see how you're using it sometimes and piece together something, but often that context does go missing, and then sometimes you do have to give Diffblue extra context. What I'll do, if we have time today, left a bit, I will show you an example of how you can give Diffblue that extra context. So to answer your question, for all the things that you mentioned, message queues, databases, etc., the connection classes, Diffblue just mocks them, so it's not actually hitting the database. The challenge arises then is the code, is there enough context in the code for Diffblue to then mock the incoming messages properly, or whether it would require some of your input?
Great. Um, are there any plans for a VS Code developer extension?
Yep, it's on the roadmap. I think this is probably the most asked ID we get. So
Yeah.
there's no specific release timeline at the moment, but it is definitely on the roadmap. I would expect it next year at some point, but that's all I know as well.
Yeah, if you are interested in the roadmap, please just subscribe to our newsletter, and then we'll make sure that you receive the updates in a timely manner. Animesh, anything you'd like to add?
Anything that I'd like to add?
Yeah.
No, I think what I'll do is I will go and try to run my test class again.
Okay.
And I'm going to expect that one of the test case should pass now, because what I did while we were waiting was asked Diffblue to just write test for one of the methods here, which is this process find form. So there was another that was failing, but hopefully this should work. If not, well, I'll just ask. Okay, it didn't. My plugin just refuses to behave. Fine, no worries. There's one last thing I'll show you. So this is the plugin. Theoretically, please pretend this worked and this class was passing again. We're back to our 80% coverage, and we can merge this code knowing fully well that we have tested the code. We have actually updated our test class to reflect the new behavior, and we are happy to then move on to the next feature ticket. There's another way to achieve this. So what we've done so far is all local. So we write the code locally, we use the plugin locally. There's one way to scale Diffblue across teams by plumbing it into your CI processes. So if you, what I've done is I've created a PR with the same exact code chain that I showed locally. So if you see that, let me make it larger. If you see here, the change I've made is I have made swap redirection with pagination. That is exactly the change that I did locally. And but if you see this commit, I have not added any tests to it. So exactly what I was trying to show you locally, I changed the code, didn't update the test, and then asked Diffblue to update it. You can achieve that in your CI as well by using Diffblue in CI. It works for all CI platforms out there. And what Diffblue will do is when you open a pull request with failing tests, Diffblue will come in, execute the code, understand why it's failing, and then push a new commit, which is this commit here, to with updates to the test cases. So what you see at code review are two things. You will see the change that I had in my commit, and you will have the resultant change in the behavior in the test suite. So what used to be a redirection, those test cases will now assert on seeing a pagination, and this is exactly what my functional brief was, and that's exactly the change that I made. Had I not broken my IDE, I would be able to, I was trying to show you this exact change in the test suite as well. But like I said, deterministic tool. So regardless of where you use it, regardless of how you trigger it, if the change is the same, which is in this case, the change was identical, you will get the identical changes in your test suite as well, because the whole tool is deterministic. So 3 ways to write test. There's a command line interface to write test at scale. That's what gave us that 86% coverage in 6 minutes. Then we made a code change and we used the IDE plugin to update our test suite. We also use the CI to get our test suite updated so that at time of code review, the developer or anyone else who's reviewing the code can see not just what the code change is, but how that changes the behavior of the application. And that is how you can catch regressions early on right there in your code review cycle. So that is covered test writing in a nutshell. One last thing that I want to show you is something that we call cover reports. So this is the application that answers the question, all right, cool, I've been doing this, I've been using Diffblue for a while. What value am I getting from this thing? So it's an analytic application that gathers data for all usage of Diffblue across your project and code bases. So it's excellent for managers, because one of the things that we hear from managers quite a lot is, well, my developers are using all of these AI tools, but I have no visibility into it. I don't know what value we're getting from it. Diffblue Cover solves that problem for Diffblue. I'll show you an example here for a project. So here, Diffblue was run. The overall coverage achieved was 72%. There are 2,000 plus tests in this project, of which 1,800 comes from Diffblue. So you get an overall coverage number. You can also see how that is distributed across different packages. So some of them are 97%, 96%, great, but some are also dawdling at like 14%, 40%. So as a developer, assume I inherited again this project, and Omar is a hard taskmaster. So he tells me Analyst is 72% is not going to cut it. I'm not going to let you merge anything until this hits 80%. And so now, as a developer, I can come to Diffblue cover reports and say, okay, cool, this is 72%, I guess it. I'm going to go, I am a developer, so I'm going to go look for low-hanging fruits and say, okay, this gRPC class looks at 60%. It will be easy to add 20% in here, and I can see all the classes that make it. And I can see that connection class at 45%. I should be able to up that to somewhere 90-ish, and then that should be job done for that class at least. So here, it's showing me all the methods. Most of the methods are 100%. Some are not, and why they're not can be learned at coverage detail. And this is where all of that context that Diffblue learns in that iterative deterministic loop comes to bears fruit, because what it will do if it can't write a unit test for a particular piece of code, it will leave behind what it calls advisory. You can see these advisories in the right hand column. Some of these are self-explanatory. So trivial getters and setters, we don't write any unit tests for them. But this async request method, 19 lines of code, seems quite meaningful. No Diffblue tests, no manual developer written tests. And Diffblue has tried writing tests for that, but didn't manage. So I couldn't find any input that didn't throw an exception. You can then click through, which takes you through a documentation page, which describes what this code means, gives you some common resolution strategies, helps you find the root cause. You plumb in the extra context or extra configuration that is required to write a better test here. Run Diffblue again. The 0% goes to 80, 90, 100. And that's how you then improve your coverage one class at a time, package by package, and you can get to that 80% target that Omer is holding to you to. And you've seen how easy it is to just run Diffblue and go do other things. So it doesn't really demand that much of your attention while it's plugging away in the background. So write a lot of tests straight away, use the ID and the CI plugin to keep that test suite in sync as you're making changes, and then come to cover reports to see how much there is left to be done, and where exactly should you focus on in an application, because some applications are quite large and there's no point writing tests for an ancillary class that very rarely gets used. So cover reports can help you figure out where you should focus your effort. The coolest thing, and that's the last thing I want to share today, is we do have an output code which also allows you to spot dead code. So this application, again, if I go back into my character, I was a developer. I got given this pet clinic application that we wrote tests for, and this application might have had some dead code. Now, I wouldn't know that unless I pour through every single bit of it. But remember, Diffblue is running every single method and trying to identify how everything interacts with everything else. So we have an output code, an advisory, which specifically highlights dead code in your project. So you can then, and we highlight that in here. So if you look at that breakdown, there's a section here which says untestable, 0.14%, and that is the part of the code that is not testable because it's not even you can't reach it. It's not reachable, which means it's dead code. No code is calling it. It's probably a private method that just sits there doing nothing. So cover report allows you to see what you've done, but most importantly, optimize your next effort so you're not wasting time on some wild goose chase. So that's Diffblue cover in a nutshell. Write bunch of tests in a matter of seconds. Write tests that tell you how an application works that you have inherited and you might not be comfortable with. But most importantly, it gives you a test suite so that you can experiment, make changes, knowing fully well that there's a test suite that will protect me from making something stupid, some stupid changes or introducing regressions. And that's how you should use AI. That's all from me. Back to you, Omar.
Great, Anish, thank you very much. We have one other question that's quite interesting and nice. In what way is this AI powered but not implemented via LLMs and probabilistic responses? In other words, is this just old-fashioned deterministic code and the AI tag is just for marketing and there's a nice smiley?
Well, well, like I said, we started before LLMs, so LLMs have sort of changed the behavior of artificial intelligence. When I was in university, we used to call it machine learning. Artificial intelligence was just for Terminator. So if we could market it, and if Omar would love to market it as machine learning, but then nobody would search for machine learning other than me in university, and then we will not get any hits. So it's a fair question. But what is happening here is we are using a machine learning technique, and LLMs are also a machine learning technique. So if you want to be very academic about it, all of these techniques are are machine learning techniques. Some of them use probabilistic methods like LLMs, like deep learning, which predates LLMs, and some of them do not. So there are deterministic machine learning algorithms that exist and have existed for quite a while. Uh, if whether you choose to call some machine learning algorithm that's deterministic good old deterministic something, entirely up to you. Fair point. I would not argue. I would say AI has basically become synonymous with machine learning. So anything or any kind of solution where which can do some part of my day-to-day job for me, I would consider it artificial intelligence, because I thought that was the whole dream of artificial intelligence, that we can get the robots to do our work. So sorry, long-winded answer to your question, but if you were very curious what is inside there, it's a deterministic machine learning algorithm using the using reinforcement learning techniques. Uh, you could choose not to call it AI, and that's fine.
That's correct. All right. I guess we are at the end of the questions. Obviously, you can always go and try. We have both trial with the enterprise level features like CI integration, CLI, etc. But we also have a community edition that you can begin using and continue using every month. That's only limited by the MUTs that we are using per month, but it's free, and we'll be glad that you try it out if you haven't done it yet. All right, thank you very much, everyone, for the participation, and thank you very much, Animesh, for the nice demo. While we are finalizing it here, I want to say goodbye to everyone, and thanks for joining. Bye.
Yes. Thank you, everyone. Have a good evening.